So up next, we have Emily Godson. Emily is a senior data scientist in Hitachi, Vantar. She has a background in mathematics and has worked for the past 5 years delivering data analysis and data science projects to clients. Most recently, she was the lead data scientist in a digital hospital project for a large NHS teaching hospital in the UK, where a range of machine learning models were developed for demand and capacity planning. Emily would be guiding us today through Sklearn pipelines. And I cannot urge the importance of this topic enough, especially if you are at the beginner or intermediate level in machine learning. Please welcome Emily. Over to you.
Yes, thank you very much for the lovely introduction. It's good to be back doing a WIDS workshop. As was kindly so introduced, I've been working for the past kind of 5+ years in data science and machine learning at Hitachi Vantar. Most recently as a lead data scientist in a large NHS hospital in the UK. So the program developed some machine learning depicting the demand and capacity at the hospital, which led to kind of powering a digital twin, which enables staff to proactively plan for demand, address future bottlenecks, and act on opportunities for improving capacity and performance. The predictive modelling was also used to create patient-level predictions that to aid the flow through the hospital. Prior to Hitachi Vantar, I was studying at university, so I first studied a bachelor's in mathematics, where I took an optional year in industry, where I worked as a data analyst. And this was where I kind of first saw the data scientist role. One of my colleagues there at the company was doing some data science work. And that's kind of where my interest kind of came from. It's really interesting to see her work and kind of the application of it in the business. So after I went back and I did my final year at university for the bachelor's, I went and did a master's in data analytics for business intelligence, which is a really long name for a master's, but it kind of focused a lot on modules in data science, how you apply that in industry, and how and some of the kind of key areas that you might apply that in industry. So today, as you mentioned, we're going to be talking about Sklearn pipelines. So we'll do a quick introduction into why pipelines are important and what Sklearn is. Then we can dive straight into understanding a bit more about Sklearn pipelines, how you might build a simple pipeline, the advanced techniques for some of the advanced techniques for Sklearn pipelines, and some of the best practices. So we shall first make a start. So Scikit-learn, or commonly known as Sklearn, it's a widely used open source machine learning library in Python. It provides a set of tools for kind of some data mining, data analysis. It also includes a number of models for supervised and unsupervised learning. It also has functions and methods for data pre-processing, model selection, and evaluation. The importance of Sklearn in machine learning lies in its simplicity and ease of use. It provides kind of a high-level interface so that individuals can implement machine learning algorithms without requiring all the in-depth knowledge of the underlying mathematics. Of course, you can also know that, but the Sklearn packages it up nicely for you. And that means that it's a bit more accessible to a wider range of individuals who want to learn more about data science or apply them to projects. Sklearn also has a large community of contributors and users, which has led to the development of more and more libraries and tools that extend its original functionality. This makes for a powerful and flexible tool for tackling a wide range of machine learning tasks. That could be your kind of classic classification or regression problems, but also leads up to more complex tasks, which we're seeing more and more of, such as image recognition and natural language processing. And so what are pipelines and why are they important? So they can streamline the workflow. So data science projects, they often have a few kind of typical steps. You might do some data cleaning, some feature engineering, some model training, and some evaluation at a high level, because there's most of the key steps that one might go through in an iterative process. Pipelines allow these steps to be put into a single workflow, which reduces the need for the manual intervention and makes it a little bit more efficient to kind of go through the whole process of. Pipelines also means that your whole workflow can be reproducible. So it can either be replicated with the same results, regardless of who runs it and when, assuming you're putting the same data in and the pipeline hasn't been touched, which makes it easier to share and collaborate on projects that you're doing, and ensures that the results are consistent. It's also, I found it's really useful. So for one of the projects that I was working on, we had a snapshot of data in time, and we did all our kind of data exploration, model development, and an evaluation on that data set. And then kind of a few, kind of 6 or so months down the line, when we're getting those models ready for deployment, we got a new set of data, and our features, or none of our features, had kind of changed in definition, but we had newer data, and it meant that we could easily just rerun the whole pipeline, and get an updated model with the most recent data, and investigate any kind of changes that might have given. Testing and debugging, because pipelines are an organized framework, and we'll go into a bit more detail on how they're kind of formed shortly, but because they have steps within the pipeline, if you want to test and debug where something might be going wrong, as it often occurs, you can kind of isolate each step and work out where kind of the error or problem that you're facing is, which makes it easier to try and pinpoint where to start looking at least. Flexibility. So pipelines can easily be, you can add more steps, or you can swap it in and out steps. So it makes it easily modified or extended to incorporate kind of the different steps. Or, if you're at the beginning of your data science problem, you might want to try different data pre-processing, or if you're a bit later on, you might want to try a few different models and see which provides the best. So you can easily swap in and out those steps, and know that nothing has changed on the rest of your pipeline. It's just that one thing that you have changed. Scalability is another reason for a pipeline. So pipelines can be deployed in production environments and process a large amount of data in real time, which is really useful when you're getting those data science models live and being used regularly. So overall, we've seen that pipelines are an important tool to in machine learning, because they provide that standardized and automated framework for your data science projects. They also can reduce the complexity by having that kind of structure to them. And so moving on to the kind of the main topic that we're going to talk about, so Sklearn pipelines. So Sklearn pipeline is a tool for building and automating machine learning workflows. A pipeline will consist of a sequence of data pre-processing steps and chained together with additional data pre-processing steps or models to give a final output. Within the Sklearn pipeline, well, in Sklearn, a pipeline is created using the pipeline class, which takes a list of tuples, which kind of is formed from a name that you want to recognize that step as, and then what you want to implement, so the transform or something. So each transform or step can be different. You can have a few different steps, and some can be transforms such as standard scalars or one-hot encoding if you've got categorical data, and then each step passes on its output to the next step, and its final step is a model, which produces the prediction outputs that we're after. And sorry, just briefly before I move on to that one, I will do a short demo a bit later on in the presentation, where we can kind of see some of this in real life, and it will kind of a bit easier to kind of understand. But once a pipeline is defined, which we'll see shortly, it can be used to process data and build the models. And so for our usual data science models, we're probably quite used to seeing the fit method and the predict method. Those are still used in the pipeline, so it keeps with that similarity of when we are building a model without a pipeline. And there we go. And we can also combine our pipelines with our cross-validation techniques that we would use to optimize kind of the performance of those models. So we can use the cross-validation and hyperparameter tuning to optimize the performance of those machine learning models. So in summary from that, Sklearn pipelines are a powerful tool for automating and standardizing the machine learning workflows. So they can enable data processing and model steps to be chained together into a reproducible single workflow, to really optimize that process. So what are the key components of a Sklearn pipeline? So transformers. So transformers are classes that transform input data in some way. They can be used for data pre-processing, so such as scaling or normalizing the data, or for feature engineering, so creating new features from existing ones. Some examples of that might be standard scalar, which standardize the data, or one-hot encoding, which takes our categorical data and puts it into multiple columns for our kind of making it numerical kind of indicator of whether it is category 1, 2, 3, for example. There are also estimators. These will usually come at the end of your pipeline, and they are classes that fit the models. They take transform data as input and they use it to learn a model. So these can be kind of most estimators that we commonly see, so linear regression, random forest classifier, XGBoost, etc. that can all fit into this. And feature unions. So feature unions combine multiple transformers into a single transformer, which is really useful when some parts of the data require different processing or feature engineering steps. So, I mean, the easiest example is if our data consists of both numerical features and categorical features, then feature union can be applied to the different feature union can be applied to be used to apply different transformers to each type of feature, so to those numerical ones or to those categorical ones. And the pipeline works by creating Sklearn pipelines are created by chaining together transformers and estimators, as well as feature unions, using the pipeline class. and by combining these, it is possible to create a powerful but flexible machine learning workflow that can handle different data types and model types. The pipeline can be fit using the fit method, as I mentioned before, and then we can use the normal predict method to get our predictions back from the model. What are the key benefits of an Sklearn pipeline versus kind of writing your own code to do all of these steps one after the other? Well, the Sklearn pipelines are easy to use. It reduces the amount of code you need to write and makes it easier to manage complex workflows because you've got that kind of step view. They are reproducible. So with pipelines, it's easy to reproduce your results because all steps in the workflow are chained together in a single object. And you can easily rerun the entire workflow with the same parameters and the same data to get the same results. Pipelines are modular, so you can easily swap out different components or add new ones as you require, which makes it easier to experiment with different combinations. And I think this one is a key one. I think it's easy to kind of think, I'll do all my experimenting and then I'll put it into a pipeline before I put it into production. But actually starting by having it in a pipeline, it means you can easily kind of swap in and out those steps in your pipeline to really experiment around and keep kind of a bit more of a track of it, and also kind of try different combinations of feature engineering or pre-processing or models. Some might work better with different combinations of that. So having that kind of modularity where you can easily swap in or out a step during your experimentation is quite key. So making sure to use that during experimentation as well as, and not just when preparing for kind of putting your model into production. Pipelines can be used to automate some of the more common tasks. So pre-processing, feature engineering, tuning, etc., which can save some time. And it means that you're always applying the same pre-processing, which is also key, unless you've swapped it out, of course. And the fact that you can use it in conjunction with your cross-validation techniques and to evaluate the performance of your models, and makes it easy to kind of implement and include. So it's a really kind of flexible tool for working with when you're developing and productizing your models. So in addition to the more basic concepts and steps involved in building an SK pipeline, there are also additional more advanced techniques that can be used to optimize a pipeline's performance. One of those would be kind of grid search. So as I said, we can apply and we can systematically test all the possible combinations of hyperparameters for each step in the pipeline. Grid search, we won't go into too much about the details of it, but that it searches through each possible combination, and it can be quite computationally expensive or time consuming. And another would be the randomized search. So it samples a different number of hyperparameter combinations at random, which allows for a more efficient search of the hyperparameter space and can identify promising combinations more quickly, as well as the techniques that we've mentioned for optimizing pipelines. We can also include other techniques within our pipelines. So they could be feature selection algorithms. We can include those in the steps. Feature engineering. There are multiple different applications that can be done through the pipelines. And it can also use ensemble learning, which is kind of combining multiple models to improve the predictive performance. Yes. Okay, going to go to the demos. So I think I've shared this right. Yes, okay. So this will be provided, I think, at the end of the workshop. So you should be able to have a quick look through, but we can start to step through and see how we would use an Sklearn pipeline. So I've just used one of the data sets that are provided from Sklearn, so load iris. So we'll just run that now. And we get some data. It's from a quite well-known data science top project, sorry. And we have some input data. In this case, it's all numerical. And we have things like sepal length, sepal width, petal length, and petal width. And then we have our target column. And now the header just gives us all zeros. So let's have a look what unique values we have. So 0, 1, and 2. And let's just check those target names that we have. So these are our kind of our target that we're going for. So it's a classification problem that we have. And so we have our data arranged into our X and Y. These are NumPy arrays. And so we can split that data. So Sklearn also has a train test split. In this case, we're using 70% of the data for training and 30% for testing. There's different combinations that different people take, but for the course of the demo, we'll use 70% and 30. And so now we're getting on to the bit the whole presentation is about. So defining a pipeline. So Sklearn has a library that we can import. So pipeline from Sklearn. And then we also import a couple of steps that we'll use in our pipeline. So we import a preprocessor. There are lots of different ones in this sklearn.preprocessing that we can look up in the Sklearn documentation. But for this example, we'll use this one. And we pick an Sklearn model. In this case, we've just gone for a decision tree classifier. There's lots of other ones. So how do we create a pipeline? So we use this pipeline class, and within that we do a list of tuples. So here we call our tuple, but we call our step by a name. So it's the step name. Here I've just called it scalar, because it's a nice short name for the description of what we're doing. And then the next one is the method itself. So we take the standard scalar and we apply it here. And then we do again the same for the classifier, give it a name and input our classifier here. So we can run that and we can have a look. When we run the pipeline, it gives us a little visual on what our pipeline looks like. Of course, this is a very small pipeline, but as you add more and more steps, it would become more and more it would become a bit longer or a bit different, but we can kind of expand these. They just have the methods in them. And so we can kind of start to go back to our typical kind of data science next steps. So in terms of getting I use in this case a grid search to do my hyperparameter tuning, and I kind of start with defining just a few hyperparameters that are applicable to the decision tree classifier. One important thing to notice is that for the hyperparameter tuner, the hyperparameter dictionary, when we put the name in, traditionally we might just put max depth or whatever hyperparameter we're tuning in. But since we have put it into this, in our case, classifier, and since we have put it into this, we need to add a kind of identifier bit at the beginning. So this is our kind of the name that I think I can get them both on the screen, the name that we defined up here, and then 2 underscores, and then the normal hyperparameter tuning, the hyperparameter name that we would use for tuning. And again, we give it some values as we would usually, and then we can call our grid search and cross-validation as we usually do, but we put in our pipeline straight into there. And we provide our hyperparameters and how many cross-validate, how many folds we want. And then as we usually do, we can call the fit method. And here we're just applying our data straight from how we've loaded it up here. We're not doing any kind of processing because that processing is in our pipeline already. So we can just call this straight away. This will run and give us the best hyperparameters and the best score. So then we want to, as always, with our data science problems, our next step is to evaluate our model, see what it's doing. So we can use our grid search that we've just fit, and we can call the predict on it, again with our test data, so that we can compare our test and actuals, and then we can evaluate the performance. So in this case, I just use a classification report because we're doing a classification problem, and it gives us a nice visual. In this case, it's got the test data very accurately. As this is a dummy set, we probably wouldn't get accuracy like that in the real world, but it gives us an idea of how we can go through with the whole pipeline. And yeah, that's a very simple whistle-stop tour of how we might include, how one could do a simple Sklearn pipeline. So I will go back to the PowerPoint. So what are the common pitfalls that we see kind of in both data science projects, and what are kind of some of the best practices we can do to avoid those? We want to avoid, obviously, the common pitfalls in data science projects because we don't want to have unreliable or unstable kind of pipelines. So data leakage is a common pitfall in data science projects, and it's important to avoid those. And it is when information from the test set is used to train the model, which gets very optimistic performance statistics. So to avoid this, we can split the data into training and test before we do any pre-processing. And because that pre-processing is done in the pipeline, it makes it easy to kind of avoid doing any pre-processing or modeling or transformations in general before the pipeline. Overfitting. So overfitting occurs when the model is too complex and learns the noise in the data instead of the underlying patterns. So we want to avoid this naturally, as we want it to perform well on unseen data. It's not seen and not kind of some of the noise. And so there are lots of techniques to avoid this. And one of those is kind of doing that hyperparameter tuning and the cross-validation part of that, which we just discussed, pipelines integrates really well with. Missing data can cause errors in some of the pre-processing steps, so such as scaling or encoding, and could lead to biased results. So another kind of transformation that can be applied in pipelines that we didn't mention is kind of missing, is like imputation techniques. So to fill the missing values or rows or columns can be dropped. Some of those imputations can be applied in a pipeline itself. So there's some imputation techniques that look at kind of what most similar neighbors look like similar values, kind of the closest neighbours have, and provide that value. And that can be included as a step in your pipeline. Inconsistent data can arise when the same feature is represented differently across samples, or when features have different scales. So handling this in our pre-processing is important, so including normalization or scaling to make sure that we have those. And then and I guess this is one that is a key common pitfall, but it's something that we would check after we've completed our pipeline, is making sure we have the appropriate evaluation metrics, so that we have an accurate assessment of our model performance, and making sure that we have the right evaluation metrics for the problem that we are looking at. And model selection bias. So this can occur when the same data is used to both train and evaluate multiple models, leading to overly optimistic results. So it's important to use a separate kind of validation set, or cross-validation, whichever kind of works. But both those fit in nicely with Sklearn pipelines as well. And so what are some of the key takeaways from today's session? So Sklearn pipelines are a powerful tool for building machine learning workflows. They allow for easy, reproducible data processing and model building. There are kind of three key components of a Sklearn pipelines that is transformers, estimators, and feature unions. Sklearn pipelines provide a range of benefits, including reusability, readability, and robustness. And when we want to apply, when we are building Sklearn pipelines, we want to think about the common pitfalls that we just discussed that are common in data science data science projects, sorry. And of course, we can use advanced techniques such as grid search and randomized search, or also kind of ensemble learning to fine-tune or improve our accuracy. And our best practices in the real world machine learning projects, so we can be careful to pre-process, use appropriate feature engineering, and proper model selection and evaluation. In the real world, we want to kind of think about whether the right data is going to be available at the time we want to do the prediction, but also making sure having that pipeline ensures that we're doing the same pre-processing that we did in our kind of exploratory, non-productionized workflows. So the next steps for say you've enjoyed this presentation, which hopefully you have. What are the next steps for learning more about Sklearn pipelines? Familiarize. So we can familiarize yourself with Scikit-learn documentation. So there's a kind of a huge amount of information on how to use pipelines, and what what kind of different transformers and models are available. There's a huge amount of documentation on that, and so you can spend time kind of exploring that documentation online and get a better understanding of the different components of pipelines and how to use them. Practice is always a key one for kind of learning more about a new bit of technology or Python library, for example, that we haven't used before. So one of the best ways is to practice building them, so on different data sets, or experimenting, swapping in and out those different steps for the different processing or engineering steps, or again swapping out the models. there's lots of different kind of data sets online. I know kind of Kaggle has quite a lot of data sets and it's quite a good one for practicing on, but there's lots of other things out there. Learn, so there might be some new techniques that you kind of either heard about here or that you see online when you're looking about it. So once you've kind of mastered the basic pipelines, there's so much more that we can learn about, even moving past the hyperparameter tuning, feature selection, maybe some ensemble modeling. There's lots of information or tutorials online, so learning more about those. Participating in online communities, so there's an ever-growing amount of communities online, which is great. Even things like Kaggle, GitHub, Stack Overflow, getting feedback on your projects or sharing your work or projects if you can. And finally, working on real world projects. So it's really great to practice and learn and really kind of build all those skills. And it's also really nice when you can see that kind of go into the real world, and you can kind of see those models go into production and be used by whoever's going to be using them. And yes, I think that is the end. So thank you very much. If there's any questions.
Thank you so much, Emily, for walking us through this. I have enjoyed this session thoroughly. And like I said before, this is so important to get the fundamentals right. So thank you so much for walking us through this. We have a couple of questions for you. The first one is by Gauri. So how do we ensure reproducibility in the steps where randomization is carried out?
So I guess if we're talking about kind of the randomized search, yeah. So generally, so if we have the same kind of data and what we can do when we're doing a randomized search is you can also provide a random seed to kind of start from. So having the same data and same hyperparameter kind of search space to use, as well as with that random seed, we can kind of reproduce the same results. I guess also if you have kind of updated data, your model might might choose slightly different hyperparameters, but I guess your steps are still reproducible. So there's two sides to it. You might want to do the random seed so you get the same results each time, or if you just kind of want to reproduce the same kind of workflow without that random seed, it will still kind of, it depends how what kind of limits you set on it, but it might still find either an equally good result or slightly better or worse, but you've reproduced the same kind of pre-processing steps.
Thank you so much. So I actually have a question on my own based on that. So is there a way to stop underfitting and overfitting when we use Sklearn? Like, are there things in Sklearn that we can kind of put in the pipeline, or is it usually a different thing that we'll have to custom add?
I think, I mean, it sort of, it depends a little on your problem. I think sometimes I think there have been some things added to Sklearn that can certainly help with kind of under or overfitting, and especially if we're thinking if there's like kind of unbalanced classes, there's certainly things to add there. But in general, when we're thinking about under or overfitting, there might be kind of something to have a look into about different techniques in the kind of pre-processing stage, or more maybe like more of a configuration of when we're looking to set up the tuning.
Okay, okay, thank you so much. The one other question that we have from Shruti is, can we add custom functions as a part of Sklearn?
Yes, so trying to rack my brain for the name of what it is, but you can add custom ones if there is not something already there. You know that a lot have been added, but I believe you can write your own transformers at least for kind of transforming your data. And I would have to check about the models if you had something that wasn't an Sklearn model. Maybe, I'm not sure about that one, but I know that you can write your own transformer, but I can't for the life of me think of the kind of the name that you use for it.
Okay,
Sorry.
all right.
I'll have a look and I can drop it in the chat after.
Yeah, absolutely. One more question that we had, Emily, is can you think of a situation where a pipeline is not favorable? Like instead of that, we would do something more static in a notebook or script.
That's a really good question. I'm not sure. So I can't think of one. So I think, yeah, because even if you have kind of, you know, a quick kind of turnaround on kind of getting, so I think that sometimes it's like it's often kind of an afterthought, like, oh, I put it into a pipeline kind of once I've kind of, you know, especially if you've got a really short deadline, as I'll put it into a pipeline once I've kind of figured it all out. But actually I think as I kind of said earlier, is that kind of having that kind of structure and steps there, you can really easily swap in and out. So say I've got a bit through and I've figured out that, yeah, this is the data that I want, and I just want to swap in and out some models and try that. It doesn't kind of save too much time to kind of do all my experimenting first and then put it into a pipeline. It kind of actually can sometimes be easier to have your pipeline ready and do the kind of swap in and out while you're experimenting.
Yeah, thank you. So we have one more question from Walter. Can you have pipeline searches that maximize an objective on the test partition if you do a test, train, validate, three-way split?
I'm not sure. I haven't looked at, so we did train, test, validate, split for our for kind of some projects that I've been on, and we didn't do it that method, but it might be possible to do it that way. We kind of ensure no kind of contamination of the validations that we kind of took that kind of to virtual one side at the beginning, and then we kind of did our cross validation with the and kind of some further testing with our train and test, and then just did the validation right at the very end. But it's not to say that there isn't. There could be. I'll have to check, but.
And what you mentioned regarding cross-validation, right? So say if we have cross-validation per se, we don't necessarily need to do a three-way split of train, test, and validate, because your chunks of your train can be used for the iterations in cross-validation. So I think that would kind of solve for it. Yes, all right. One last question that I had from my end was, so one thing that I have realized in my few years of experience is from a scalability perspective, sometimes I kind of have to waddle between SciPy, I think that's it pronounced, SCIPY, and Sklearn, because there are certain functions that are better for Sklearn, certain functions that, like when you're dealing with large data, big data, it does better for SciPy. Do you have any recommendation or anything that you might have come across in your experience?
I haven't come across having. I've heard of people having to kind of use a combination too. In kind of the cases I've been involved in, it hasn't, I guess, for kind of, but when we're thinking about the kind of the real-time one, it's not been that large that there's been too much of a problem with it at the real-time phase. And then even during training, the Sklearn was worked fine. So I haven't come across that one myself, but I have seen it on some of like Stack Overflow and things. So I'm sorry, I can't help with that.
No, that's all right. Thank you so much, Emily. Thank you once again for walking us through this. Like I said, it's a super interesting, super important workshop that we are featuring on Sklearn pipelines, especially for folks in the industry. It's pretty much going to be their bread and butter for quite a while.